Object-oriented programming concepts have solved major complexities in programming methods. One of the most important object-oriented programming method is the inheritance. Hello everyone, I am Ravi and I welcome you all to yet another tech enthusiastic video from Edureka. Today we will be discussing about inheritance in Java. Before getting started, let's take a quick peek on the agenda for today's discussion. We shall begin with understanding why exactly we need inheritance, where I will be explaining you the importance of inheritance and its functionality. Later, we shall discuss about inheritance in Java. Followed by that, we shall look into the different types of inheritance, and finally, we shall understand method overloading and method overriding in Java. I hope I'm clear with the agenda. So, without wasting much time, let us quickly begin with our first topic. Why do we need inheritance? To understand this, let us consider a simple example of two different watches. First one is a classic dial watch and the next one is a modern digital watch. The functionalities defined for a dial watch are display date, display day, and display time. Similarly, let us get into the advanced version of the watch, which would be our digital watch. The functionalities required for the digital watch are as follows: display day, display date, display time, light, set alarm, and set timer. As you can see, three functions from the dial watch are repeating here. In real time, this would be considered as code redundancy. You might avoid by removing the extra code from the digital watch, but it results the digital watch will be missing the three functionalities, which are display time, display date, and display day. You might try to keep them in the digital watch and try to remove those from the dial watch. But again, in the real-time scenario, you will lose the existence of dial watch. The only solution for this problem is by applying inheritance to both the classes, where the dial watch will act as a parent class and digital watch will act as a child class. The child class will inherit all the methods and properties of the parent class and successfully reduces the code redundancy, improves the readability, and the functionality of the code to an exponential level. Now that you have theoretically understood what the term inheritance means, let us now get into Java inheritance and understand it through an example. Like any other programming languages, Java inheritance is also known as a procedure where the child class inherits all the methods and properties of the parent class. As you can see, the tablet here is inheriting the properties both from laptop and a mobile phone. This was a pictorial example. Let us see a practical example through a code. In this particular example, we have two classes. The first one is teacher, which acts as a parent class. Inside the teacher class, we have two strings, teacher and Edureka. Along with that, we also have a print statement which has teaching message inside it. Now, let us get into our child class. Hadoop teacher happens to be our child class, and in our child class, we have a string called as Spark. Now, we will be performing a print operation which has to access the college name, designation, and the main subject. As you can see, we have the main subject inside our child class and college name and designation of the lecturer in our parent class. Now, we'll try to inherit the parent class through the keyword extends. And this is the name of our parent class, which is teacher. Now, let us try to run this program and see the output. As you can see, we have successfully inherited both the messages from the parent class, which is Edureka, which happens to be the college name, and the designation, which happens to be the teacher, and the main subject, which is Spark. This is been displayed from the child class, and the message from the parent class, which is teaching. Now that you have understood Java inheritance in a practical way, let us now get into the types of inheritances supported by Java. Java basically supports four types of inheritance, namely single inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. Let us discuss each one of them in detail. Firstly, single inheritance. Single inheritance is a procedure where one child class inherits the methods and properties of one parent class. In simpler words, the whole system consists of only two classes, one parent and one child. Let us understand this through an example. Here, we shall consider two classes. One class will be person and the other class will be employee, where the person class acts as a parent class and employee class acts as a child class. Let us execute this program practically. You can see here that this happens to be a parent class, which is person, which has two different functions. The first function is set age and the second function is set name. Now let us move on to our child class. Inside our child class, we have one method which happens to be set employee ID. The methods set name and set age, which are in the parent class, are required in the child class as well. So let us try to inherit those into this child class. So this is the code for inheriting the properties of the parent class into the child class, where I'll be inheriting the properties of getName and getAge into my child class to display the data of a particular employee in an organization. Now let us try to execute this program and see how does it work. As you can see, the properties of getName are inherited, and I have successfully named my employee as Raghuveer, and I have set the age of Raghuveer as 23. And accordingly his employee ID is EMP1101. So this was single inheritance. Now let us move into the second one, which happens to be the multi-level inheritance. Multi-level inheritance is a process where multiple child classes inherit the properties from their preceding parent classes. To understand this in a better way, let us consider a simple example. As you can see in the picture, class A is the parent class and class B and class C happens to be the child class. Here, child class C is inheriting the properties from its preceding parent, which happens to be class B, and class B is inheriting the properties and methods from the superior class, which happens to be class A. This was a pictorial representation. Now let us see a practical example through a code. As you can see, this is our program, and calculator is our parent class, similar to class A in our picture, which performs basic mathematical operations such as multiplication, subtraction, addition, and division. Now let us move into our class B, which would be the class Advanced. Advanced class can perform a little advanced operations such as modulus of a number, square root of a number, and square of a given number. And now let us move on to our child class C, which happens to be the area. So this class can perform a little advanced calculations such as finding an area of a geometric figure such as square, rectangle, and circle. Now we need a calculator which could perform all these operations in one single class. For this, the only solution would be multi-level inheritance, where we will be inheriting all the methods and properties of superior parent class into the succeeding child classes. Now we have tried to inherit all the properties and methods of the preceding parent classes into the last child class. Let us try to execute this program and see the output. As you can see, the values are already passed to all the functions. Now their respective outputs have been successfully displayed. So this was multi-level inheritance. Now let us move on to the next one, which happens to be the hierarchical inheritance. Hierarchical inheritance is a procedure where we will be having multiple child classes, and all the child classes will be inheriting the properties from the major parent class. Here, let us assume an example of a restaurant. We shall have 4 different restaurants here. The first one would be a parent restaurant, and the other 3 will be Chinese restaurant, Italian restaurant, and Mexican restaurant. The parent restaurant will be having various types of ingredients which the child classes might need in their dishes as well. Let us see this practically to understand this in a better way. So this would be our parent restaurant, which will be having the ingredients like bread, vegetable stew, and cheese. Now let us get into the first child class, which happens to be the Chinese restaurant. The Chinese restaurant already has noodles and momos. To cook their special dishes, they might need vegetable stew and cheese. Similarly, let us get into Mexican. Inside Mexican, they already have nachos and sweet potato for their special dish. They might need cheese and vegetable stew or even bread for making some better dishes. Similarly, let us get into Italian, which have pasta and sausage available. So to prepare their special dishes related to sausage, they might require bread, and to prepare their special dishes related to pasta, they might require cheese and vegetable stew. So how does all these 3 restaurants get their ingredients from? Simple. They apply hierarchical inheritance and inherit all the properties from the parent class and cook their special dishes. Now let us run this program and see how does it work. As you can see, all the child classes have successfully inherited their parent, and the data is also being displayed. The first one is the Italian restaurant. So they have requested for bread, vegetable stew, and cheese from the parent class, and they say that they already have pasta and sausage available with them. Now the second one happens to be the Chinese restaurant, and they say that they have requested for bread and vegetable stew from the parent class along with cheese, and they have noodles and momos already available with them. Similarly, the final child class happens to be the Mexican restaurant, and they see that they have also requested for bread, vegetable stew and cheese from the parent restaurant, and they already have nachos and sweet potato available with them. So this was an example for hierarchical inheritance. Now let us move on to the next one, which happens to be the hybrid inheritance. As simple as the name suggests, hybrid inheritance can be a combination of any other inheritances. As you can see in the picture displayed here, you can see multi-level inheritance here and hierarchical inheritance. So these are the two combinations of two inheritances possible in Java. The overall inheritance pattern can be called as a hybrid inheritance. Now you might be wondering about another possibility in inheritance, which might be obviously the multiple inheritance. Here, one single child class can inherit all the methods and properties from two or more different parent classes. But sadly, in Java, this results in a diamond problem and could not support multiple inheritance. It is possible to achieve this behavior through Java interface. With this, we shall move to our next topic, which is is_a and has_a relation. Is_a relation basically deals with inheritance and interface. Any child class which inherits or implements a parent class is said to be in a is_a relation. Coming into has_a relation, it uses instance variables to reference the objects of the parent class. This might be a little confusing. Let us understand it practically. As you can see, the BMW car is a vehicle which is inheriting the properties of a vehicle. So it happens to be in a is_a relationship with vehicle. And coming into has_a relation, it has an engine. So the BMW car is referencing to an object of engine class and said to be having an has_a relationship with engine class. Let us execute a program and see this practically. As you can see, my child class is BMW and it is extending to the parent class which is car and also extending to another parent class which is Java. So BMW class is in an is_a relationship with car and in an has_a relationship with engine class. Now let us execute this program and see how does it work. As you can see, the class BMW has successfully inherited both the classes which are car and engine, and the properties which it inherited from car class is the color which is blue and the speed from the engine which is 256. With this, let us get into our last topic, which is method overloading and method overriding. Method overloading is defined as a procedure of having two or more methods with the same name within a single class, provided the argument list must be different. Method overloading is divided into three types. The first type would be having different number of parameters, and the second one will be having different types of data type, and the third one will be the variation in the sequence of the parameters with different data types. Let us see each one of them practically. This particular example is the first type of method overloading. Here in our parent class, you can see we have two functions on the name of display. So the first display method has one parameter which is a character type, and in the second display method we have two parameters, one is of a character type and the other one of an integer type. So from the child class I am inheriting these both methods, and one of the object has one single parameter which happens to be the character type, and the second object has two different parameters. One of it is a character type and the other one is an integer type. Let us execute this program and see how does it work. Here you can see the output. The first one is calling the first display method with one single parameter, and the second one is calling the second display method which has two parameters. Now let us see the second type of overloading. In here we have two display methods in our parent class. One of the method has character type of data type and the other one is having integer type of data type. In our child class I am passing character type of data to the first display method and integer type of data to the second display method. Now let us try to execute this program and see how does it work. As you can see, the data has been successfully displayed. The first one is calling the method display with character type, and the second one is calling the method with integer data type. Now let us see the third type of method overloading. In here we are having the same two display methods in the parent class. One of them is having the character data type in the first position and integer data type in the second position, and vice versa in the second display method. Now similarly, through my child class I am passing two different parameters. The first object will be passing character data type in the first position, an integer in the second one, and the second object in the vice versa. Now let us execute this program and see how does it work. As you can see, the message from the first display method is being executed here, which shows that the first object is referring to the first display method and the second object to the second display method. Now let us take a step further and understand type promotion as well. In one of my display methods, I have provided character and double attributes, whereas float and character attributes in the object. The interpreter will implicitly promote the data type of the object from float to double. This type of promotion is valid since there was no other display function with matching attributes. Now let us try to execute this program. As you can see, the object has selected the first display method and upgraded the float to double. The message from the first display method is being displayed here, which happens to be function1. Now let us try an example where we shall have a display function with matching attributes and verify if the promotion is accepted or not. As you can see, the object display is passing two data types, which is an integer1 and float1. And here we have the first display function with float and integer data types. Let us try to execute this program. As you can see, we have the output. Now in this scenario, there is no type promotion since there is already the data type which is available and the parameters are matching. With this, we shall get into method overriding. Method overriding is a process where both the child and parent classes have the same methods. There are also some rules for method overriding which say the argument list of the child class should match the parent class. The second one is access modifier of the class should be less restrictive than the parent class. And the third one is local parameters cannot be overridden. Local parameters in the sense the parameters with access modifiers as private, static, and similar ones. Let us see each one of these rules practically. So let us execute our first example. Here we have defined two objects which are pointing to the display methods. The first object implements the display method from the parent class, whereas the second object implements the display method from the child class. This happens in the runtime. Hence, this process is called as runtime polymorphism. Let us execute this program and see how does it work. As you can see, the display methods are being implemented and the data present in the methods are also displayed. Now let us discuss about some key points of method overriding. First one, the argument list of the child class should always match the argument list of the parent class. Second one, the access modifiers of the child class should be less restrictive when compared to the parent class. Let us see this practically. As you can see, in my example, the child class has an access modifier as public and the parent class is having an access modifier as protected. This program will be executed without any errors. Let us try to execute this. As you can see, the data has been also displayed, which says the child class method is being executed. Now let us try to change the access modifiers. Now the only change what I have done is, I have changed the access modifier of the parent class to public and the access modifier of the child class to protected. As you can see, the Eclipse editor is throwing an error which says that the child class cannot have an access modifier which is highly restricted than the parent class. Now let us discuss our last topic, which happens to be about the super keyword in method overriding. The keyword super can be used in the child class to call the method defined in the parent class with its name. The super method is used to invoke the constructor defined in the parent class. Let us see this practically. Using super keyword, I am calling a method by name myMethod from the parent class. Now let us try to execute this program and see if it can successfully call the method or not. As you can see, it has successfully called the method from the parent class and the data is also being displayed. Now with this we have come to an end of this session. I hope you have understood inheritance in Java and examples explained. If you have any queries regarding this session, then please feel free to write them in the comment section below. Till then, thank you and happy learning.